Hello everyone, I'm Gauri Krishna. I'm a BTech third year student at CSC Karunya University. So today we'll see the fourth experiment in MLT lab, which is simple lab as perceptron. So we can see the code. Okay. So okay. So this is basically based on the single layer perceptron. So uh, the single layer perceptron means there will be only one single layer, one for an input and one for output. There won't be any hidden layers. And we are using the dataset iris SLP. So it's one of the simplest type of artificial neural networks used for the binary classification problems, and it consists of the input features, weights, and the bias and activation functions. So the perceptron learns by updating the weights based on the classification error here. So first, so here the first question is for reading the dataset. So we have used the IRIS SLP dataset. So we have printed the five rows, first five rows. And second one is data pre-processing. So here data pre-processing means before training the data model, the data set, it should be clean, like null values, missing values, nothing. So it is used um, the pre-processing, and there are two pre-processing steps are done in this step, which is handling the missing values and label encoding. So handling the missing values means if there exists any missing value in the data set, they are replaced with the main value of the column using the fill now option here, and this process is called data imputation. And label encoding means the machine learning models cannot work with like categorical values. So therefore, will like the column is converted into the numerical value using a label encoder from the scikit-learn. So here we have used that, and then uh, and the third question will select the features and the target. So here we separate the input features and the target variables. So here the input features are sepal width, sepal length, petal width, and petal length. The target variable is species. So here this will represent the independent variables, and species column here the target variable, it is dependent variable. And in the fourth question, it's basically feature standardization. Feature scaling is applied using the standard scaler. So here the standardization ensure that all the features have mean equal to 0 and the standard deviation is equal to 1. So this helps to predict the perceptron learns faster and like more efficiently. So this is the main goal of the main and standard image. And then the fifth question will split the data set. It's basically the splitting of data set. Here the training will split the data set into training data and testing data. So here the training data is like almost 80 percentage and the testing data is almost 20 percentage. And this is done using the train test split, this one. And training data is used to train the model, while testing data is used to evaluate or test the model performance. And here in the sixth question, we will initialize the model parameters, which is we initialize the perceptron parameters like learning rate, number of iterations, and the initial weight bias. And also we create a list of errors to store the number of misclassification during the training. So here we will get the output like this. Learning rate approx, and approx means it's basically like the time complete or the time take to complete our one full circle in our training model, and the initial weight and initial bias. And the seventh question, we train the perceptron. It's basically training the perceptron. The perceptron training process runs for like multiple epochs. It's basically not a single time. It will run for multiple time. And for each training sample, we'll calculate the linear output, which is linear output is equal to dot product of input, the features, and the weights plus the bias and apply the activation function. So the activation rule is that if the output is greater than or equal to zero means it is predicted class is one. If the output is less than zero, the predicted class is it will be zero. And also we will update the weights here. And for updating the weights, the weight updated rule, new weight is equal to old weight plus learning rate into error into input feature. So here we'll update the bias, and so bias is equal to bias plus learning rate into error. So this process repeats until the model learns to classify the data. And eighth one will display the final weights. So here after training is complete, we'll print the final weights and final bias. So these values represent the training model parameters. And in step 9, we'll plot the training error, which is basically a graph is plotted here. It will show iteration versus the number of misclassification. So this helps us to observe how the training error decreases over time. So if the error decreases means the model is learning successfully. So here we can see the error is like decreasing here. So the model will be successful. And then the 10th question will predict predict the test data here. So after training, the model is tested using the test data set, and for each test sample, we'll calculate the linear output and we'll apply the perceptron activation rule and we'll predict the class label. So the predicted values are stored in the y test trend. All the predicted labels will be stored in y test trend. So this is the output. And the level 11th question is the model evaluation. Finally, the model performance is evaluated using our confusion metrics here. Uh, Confusion matrix, and it will show the true positive, true negatives, false positive, and false negative. So the accuracy, it will print the accuracy, which measure how many predictions are correct out of total prediction. And accuracy means it will be correct predictions divided by total prediction. And precision means it measures how many here, precision means it will predict how many like how many predicted positives were actually correct. So yeah, and recall means it measures how many actual positives were correctly like identified by the model. And F1 score basically like the harmonic mean of precision and recall. F1 score is also given here. So yeah, this is all about the fourth experiment. So in this experiment, we completely implemented a single layer perceptron model using the iris dataset, and we processed the data, feature scaling, model training, and weight calculation, prediction, and performance evaluation. So here basically it will demonstrate how a basic neural network can learn to classify the data using a weight adjustments. So yeah, this is all about the fourth one. So yeah, thank you.